This is our party system or party box, and it's currently not working on its best. The volume control is very scratchy, and also the power mains, it doesn't turn on mains, but it charges the battery. It works on mains, it charges the battery, but it won't turn on. So it works on battery. When I set it to battery, so you have the system on, and you can switch this one to Bluetooth, so I can connect. So you can see it's very scratchy, and then today try to repair this one. I'll show you how I could repair this one. Okay, we'll open the top cover. Here we can see the internal parts. So we have here the main controller, and we have the switch here for the DC and mains switch. In this side here is the Bluetooth module. So we will remove these potentiometers for cleaning, and I'll also remove this equalizer for cleaning. So we have to remove the rig amplifier cover to get access to the amplifier and the power supply. Okay, let's try to remove the power supply module. This is the you can see the battery inside. So this part here is the power supply and amplifier module. So we'll try to have a look what's the problem with this one, and we will have to remove the battery for now. Okay, let's identify the module, and in this module here, so we can identify that this is the main power amplifier. It's a hybrid amplifier which is mounted into the big heatsink. So also this part here, possibly because this is the main power supply, you can see that it's encircled with the black line. So this is our main plug socket, and if you follow this wire, it's going to here. So this part here, this is the filter side, so you can identify that this is the common mode choke filter, which is for EMI, and this is the big capacitor for filtering DC. So it must have a bridge diode somewhere here. So you can see there's a 4 diodes, 1, 2, 3, and 4. So these 4 diodes are bridge diodes. So after the bridge diode, it goes into this either a BJT or a MOSFET transistor. So this is the switching transistor. Well, so it's actually a switching power supply, unlike what I thought was a linear power supply using a transformer, but actually it's not. So this is a switching power supply. It has a switching transistor, and it goes into this flyback. It's called a flyback topology, this type of power supply. So it's so there's the transformer, and this primary transformer here, and the secondary. This transformer doesn't run at like 60 hertz. It's running at about 100 kilohertz to 500 kilohertz, around that area. So this is the feedback for controlling the output voltage. So this is an optocoupler here. So we can see that there's another one here, which is the filter capacitor on the secondary. So to get a DC output, filtered DC, we must have some sort of what do you call this, Schottky diode or rectifier diode. So I believe the rectifier diode must be this one here. So they're using a 2 Schottky diode in parallel. so to get more current capacity. So on this part here, supply to the main amplifier and also to the Bluetooth and other front end on the top modules. So let's try to reverse engineer and try to get the schematic or rough schematic diagram so you can see the circuit when I'm trying to probe the voltage or where I probe the voltage, so you can see. So this is the schematic diagram that I have created from the circuit board. So here we start. Here is the main supply coming in, 110 volts to 240, 50, 60 hertz, and the fuse is about 1.5 amp. So it goes into the common mode choke through PTC, or this is a transient limiter. So on the neutral side, it goes to the double pole double throw switch. When you switch to AC, this will short circuit, which allows AC to go through the common mode choke. Then after the common mode choke, it goes to a bridge diode, which the AC rectified, and then it allows only the DC side here, which you have roughly 300 volts DC. So the negative, with respect to the negative side, so the capacitor is about 2200 UF, 450 volts. So the capacitor, the filter capacitor, and it goes into switch mode transformer, so switching transformer. So this one here also have a snubber, which I haven't drawn the snubber. There's some components here, resistors, and some diodes for snubber circuits. So it goes to the, so we have here is the MOSFET, which is HW7N65F. So this MOSFET allows the switching of the transformer. It switched the transformer to around like 100 kilohertz to 500 kilohertz, so a very high frequency. So here is, we have this 0.1 ohm resistor to the ground. So there's two different grounds, one ground for the hot ground and one for the anode ground. So the anode ground is this side and the hot ground is that side. So the gate has, I can see that the gate has a resistor gate drive with a diode, some protection diode, and it's driving from the pulse width modulation PWM circuit or chip. So this chip is the OB2269 pulse width modulation, which the pin 3 of this circuit is coming from this. How this circuit started is coming from the 300 volts rail through a 4x560K resistor, which is startup resistor to power up this pulse width modulation chip. So once it powers up, it gives a drive to the gate, switching frequency, and allows this transformer to switch on and off. So the secondary AC, this one still AC switch DC. This is high speed rectifier, so YG92C2. Then it goes to the DC, which is our DC supply to the amplifier, so the power amplifier. So through a small inductor, so the BCC. So the secondary also have the filter capacitor, so to smooth the capacitor on the output DC. Sorry, that's 100 only. My apology. So 100 UF. This is the 22 UF, 25 volts. So the output, the DC output, which around 15 volts, it's connected to the resistors, 4 by, I think there's a 5 ohms, 3 by 5 ohms resistor. into a diode to the switch here. So when you switch to DC, so it disconnect the AC power from here, and this one it powers only from the battery, internal battery. So when it switch to AC, so it allows the AC to go through, power up the whole system, and also this will be connected. So the VCC, which is the supply voltage from the switch mode power supply, will connect directly to the power amplifier. So, and also at the same time, this positive is also charging, goes to the resistor, to the diode, then to the fuse, which is 10 amps, to the battery. So it's charged the battery once it's AC. Now the problem with this one is it doesn't work. It doesn't, once you charge the battery, there's no voltage on here. There's no voltage here. So what would be the problem, you think? No voltage here. So the AC is on. This one is switched to AC, and you have the power from VCC goes to the, it charges the battery through the resistor, through the diode, and also it should, from the supply voltage, it should power up the amplifier at the same time. Now the problem is there's no power on the amplifier when you switch to AC. So obviously the problem is right here on the main switch. There is a problem on the main switch, so we have to check this one, and we'll see if we get it right. But I am 100% sure that the problem would be here, because it charges the battery but it doesn't power up the amplifier. The amplifier is a TDA. So the output amp is a TDA 7851L. So this TDA 7851L, it says it's a breakthrough technology class AB audio power amplifier in FlexiWatt 25 package, designed for high power car radio. So it's a high power 4x48 watts MOSFET quad bridge amplifier, or a power amplifier, which driving the 2 ohms of the speaker. And I'm not surprised why this unit is very, very loud, and it's really, really good. The sound is really clear, and this TDA 7851 is also powered from 8 volts. Can be powered from 8 volts to 18 volts. So it's mainly for car radio. So we'll have a look at the circuit, and we'll see if this one is not working properly. Anyway, this is how I fix electronic circuit without a schematic. I'll try to reverse engineer and recreate the schematic in order for me to understand how the overall circuit works. So for this one, it's quite straightforward, and it's easy to understand how the overall circuit works. I hope you find this one informative, and don't forget to subscribe to my channel, and I'll do more videos, similar videos like this. So let's go with troubleshooting now. Okay, first is we need to check this AC connection here. So that connection is this two here. So when you switch to AC, should be connected, then off, then DC should be nothing. So that's good. Now the other side, we switch to DC, we switch this connection if this one is connected. So this is from the fuse to the switch and to the power supply. So this one here, this is the fuse going to the switch, and this one going to supply to the power amp. So we'll check these two connection here. So when you switch to AC, should be off, and when you switch to DC, should be on. So it's good. Now the final one is this one. This is what I suspect this is the problem. So the middle one goes to the power amp, which is the bottom terminal, So what we're going to test is the middle and the left. So the middle here is the bottom part and the top. So the bottom and the top, which is we're going to test. Okay, so when you switch to DC, should be off. So when I switch to AC, should be on. Nothing. It's nothing. So that's a problem. Anyway, I would like to show you the voltage reading of the circuit board. So this is the DC side after the rectifier. So we have around 300 volts. And on the secondary of the transformer, set it to 20 volts range. So this is the negative side here, and this is the positive side is after the rectifier. So this side here. So this is the positive and this is the negative side. So we have the 15 volts goes to the battery. So it goes to the battery terminal. So the battery terminal also is we get 15 volts here or 14 volts. So with respect to negative, this is the goes to the amplifier output, and there's nothing here. There's nothing. So when I switch to battery, with respect to negative, so we have the 12 volts coming from the battery. So let's try to fix the switch. So just for disclaimer, please don't do this at home if you're not expert or you're not familiar with main supply or not confident enough to work on mains. And if you work on mains, never touch the main side because you get electrocuted. So even the DC after the mains bridge rectifier, never touch this side here because you also get electrocuted. So even the DC side, you get electric shock. So that's why this part here it's identified as hot because it can kill you. So never touch this side here. First is we try to clean the switch with this contact cleaner. So we'll see if we can get it to work. So we'll try to put a WD-40. Okay, we'll test it. We'll set it to DC. So this one's on. This one should be off. Okay, we switch to AC. This one should be on. And this one should be on. Now it's working. Okay, now we switch to DC. Should be on. Yep. Off, and then AC. It's working. Okay, the next part is we're going to fix the controls. Let's take this one out. And also the equalizer. Let's take this power. So also this one, need to take this one out. So we're going to remove this part here. So we're going to clean this one or replace the potentiometer. Okay, let's assemble this one. Okay, let's try it. So let's set it DC. It's working. Not scratching. We set it to AC. It's working. So we'll set to Bluetooth. Let's play. No scratch. Okay, thanks for watching, and I hope you enjoy this repair, and hopefully you'll find this informative, and I'll see you next time on my other videos on electronics. And please don't forget to subscribe on eCircuit. I'll teach you more on electronics, and I'll cover a lot of electronics repairs. See ya. Bye bye for now.